This is Calculus 12, Chapter 2.2. We're going to be exploring more limits. And this was the precise definition of a limit. You should be looking at this video if you are going into the more advanced calculus. Okay, let's look at a theorem. The Sandwich Theorem, also called the Squeeze Theorem. This upside down A means for all. And please, you can use different letters, but use corresponding letters for functions. So it doesn't always have to be F, G, H. It could be G, F, H, however they say it in their textbook. So the squeeze theorem says, if f of x is less than or equal to g of x is less than or equal to h of x for all x not equal to c in some interval about c. So that means on either side of c. And we have the limit as x approaches c of f of x, and the same limit for h of x equals L, so some finite number. Then we have the limit of x approaches c, g of x equals L. So we're not doing the proof of this, but if this lower function is equal to the upper function, and they equal the same limit, then we know that g is going to be equal to that same limit. Well, let's look at an example. We have g of x equals the x to the power of 4 cos 1 over x. Find the limit as x approaches 0 of g of x. Because this is an oscillating function, this is the one we need to bound. And it's convenient because it's oscillating. So we have a range. -1 is less than cos 1 over x is less than 1 if x does not equal 0. So let's take that further. If x does not equal 0, we need to make this look like this. So we have to multiply by x to the power of 4, the whole expression. So we have negative x to the power of 4 is less than or equal to x to the power of 4 cos 1 over x is less than or equal to x to the power of 4. So f of x equals negative x to the power of 4, and h of x equals x to the power of 4. Now we need to find the limits of these two. Limit x approaches 0, f of x, and we substitute limit x approaches 0, negative x to the power of 4, and that equals 0. Now we need to do the limit of h of x, and we substitute, and we get 0. And now we substitute again. 0 is less than or equal to x to the power of 4 cos 1 over x is less than or equal to 0. Since both of these are the same, we can use our theorem. Therefore, by Sandwich Theorem, limit x approaches 0 of x to the power of 4 cos 1 over x equals 0. Questions for squeeze theorem generally don't get harder than this. Horizontal asymptotes. So we've done horizontal asymptotes in pre-calc 12, and this formalizes it. The line y equals L is a horizontal asymptote of the curve of f of x if we have either limits at negative infinity or positive infinity, f of x is equal to L. We're going to look at this example, but we need to look at these theorems first. If r is greater than 0 is a rational number, then we have the limit as x approaches infinity of 1 over x to the power of r equals 0. Similarly, if r is greater than 0 and is a rational number such that x to the power of r is defined for all x, then the limit as x approaches negative infinity of 1 over x to the power of r is equal to 0. Now we just take the limit. X approaches infinity, 1 over x equals 0. So y equals 0 is a horizontal asymptote of f of x. And we can do a similar argument at negative infinity. Now, the limit rules apply for c is equal to plus or minus infinity, but we're not looking at the definitions that show this. Okay, let's look at an example. Limit as x approaches infinity of this rational function. The way we do this is we need to use these theorems, this one and the one above. And in order to do that, we need to find the highest power and divide every term by that power. And for this problem, it's x squared. And we simply distribute to each term. And now we need to use the limit rules and split up each term because we cannot take the limit of multiple terms. Okay, now we can evaluate each of the limits. This is 3, this is 0, this is 0, and we're using that theorem. And this is 0, and this is 0. So our answer is 3 over 5. Vertical asymptotes. The line x is equal to c is a vertical asymptote of the curve of f of x if either case the limit as x approaches c from the left, and this minus sign is a superscript, of f of x equals plus or minus infinity. And similarly, if the limit as x approaches c from the right, that's a plus sign superscript, f of x equals plus or minus infinity. And a hint here is we use the NPVs. And we did this in pre-calc 12. So 3x minus 5 equals 0, 3x equals 5, x equals 5 over 3. So we take the limits. Limit x approaches 5 over 3 from the left, square root 2x squared plus 1 over 3x minus 5. We know the square root is always positive or 0, but in this case it's always positive. And we have something slightly smaller than 5 over 3. We're multiplying it by 3, so it's going to be slightly less than 5. The denominator is going to be negative. And we're going to negative infinity. Let's take the right limit. And that's a plus sign. Okay, again, the numerator is going to be positive. this is going to be slightly bigger than 5 over 3. If we multiply that by 3, it's slightly bigger than 5, which gives us a positive denominator. And this is going to positive infinity. So, vertical asymptote at x equals 5 over 3. But the limit x approaches 5 over 3 d and e does not exist. First of all, because these two don't match. Remember, the limit exists if the two limits match. And this is called an infinite discontinuity. Finding n behavior models. So we have the definitions. The left n behavior model for f. This symbol means if and only if. Which means it's a biconditional. So if we have this case, it's this case. And if it's this case, we have this case. So if and only if the limit as x approaches negative infinity, f of x over g of x equals 1. And we have a similar definition for the right n behavior model. Now, the left and right n behavior models may be different functions. Let's look at an example. Polynomial rational functions are straightforward. All we have to do is look at the highest power term in the numerator and the denominator, and that's going to be our g of x. Okay, so our g of x equals 8 x to the power 6 over negative 4 x squared. And this simplifies to negative 2x to the power 4. And now we have to take the limit. X approaches infinity. F of x over g of x. And you're going to have to do some work, and it's going to equal 1. So that's going to show that this is the n behavior model. It's very similar to the work we did up here. And you're going to have to do the same thing for the left n behavior model. One last example. This one's a little bit more difficult. This is where the right and left n behavior models do not match. So first, we note going left, negative x dominates. Because e to the x is going to approach 0. So g of x equals negative x. So now we take the limit. X approaches negative infinity. F of x over g of x. And we substitute. Now we split up the terms. And we don't have the tools to formally evaluate this. But we note that this is going to 0 and it's divided by something big. So we'll just use that explanation for now. Sorry, this is a plus. We have plus, and we simplify. X approaches negative infinity of 1, and this becomes 1. This becomes 0. The particular rule for evaluating this is called L'Hopital's rule, but we won't get to that until chapter 8. So h of x equals, and we note that going right, e to the x dominates. And we can use our calculator to check this. So h of x equals e to the power of x. Now we do our limit. X approaches infinity. F of x over h of x. Substitute. And we break up our terms. And we can simplify this. And again, this would be L'Hopital's rule, and that's going to go to 0. So our limit is 1. So for the homework, you'll need to use the int function on your calculator to solve some of the problems. And that completes this lesson.